Okay, let's pull back the curtain on a single day. A day you might think is just another random date on the calendar, but one that secretly connects some of the greatest minds in history.
And that date? It's April 6th. Now, you might not have heard of it in this context before, but trust me, it's one of the most important dates in the history of mathematics. And in the next few minutes, you're going to see exactly why. So get this, on this one single date, but across completely different centuries and countries, brilliant minds changed the world that we live in today. So let's meet them, one by one. Our story begins, maybe surprisingly, not in some stuffy lab. No, we're heading to an artist studio where a compass and a ruler were about to change the world of art forever. I mean, really think about it. It's the heart of digital magic, isn't it? How do you create that incredible sense of depth, that feeling that you could just step right into the screen?
Well, the answer goes way, way back, all the way to April 6th, 1528, and a German artist by the name of Albrecht Dürer.
You see, Dürer was absolutely convinced that great art had to be based on science. He dove deep into geometry to master perspective, basically figuring out how you project a three-dimensional world onto a two-dimensional canvas. And those very principles are the direct ancestors of the 3D graphics that power our games and movies today. It's wild. And this quote just says it all, doesn't it? Dürer believed geometry was the ultimate truth. It was like a universal language that everyone had to believe, simply because it was provable. So, our journey kicks off in the Renaissance. But now we're sticking with that exact same date, April 6th. And we're jumping forward nearly 300 years to solve a completely different kind of mystery. So let's move on to our second architect of April 6th. We're diving into the world of algebra to explore the incredible power of proving something is, well, impossible. I mean, think about that for a second. It's one thing to just not be able to find a solution, right? But it's a whole other thing to actually prove that a solution can never, ever be found. How is that even possible? The answer lies with a young genius named Niels Henrik Abel. And tragically, he died in poverty on, you guessed it, April 6, 1829, just after he had cracked this very problem. You see, for centuries, mathematicians had been hunting for a single formula to solve any fifth-degree equation. Abel came along and brilliantly proved it was impossible. But his other work? Wow, that had an even bigger impact. He explored these complex curves known as elliptic functions, and the math he developed to describe them is now essential for modern cryptography. Yep, the very thing that keeps our digital information secure. And it wasn't just a small deal. Even the great mathematician Legendre recognized his genius, writing that Abel's work placed him in the class of the foremost analysts of our times. This wasn't just praise. This was a major acknowledgement that a young, unknown mathematician had just completely changed the game. Okay, so let's recap. One single date has already connected Renaissance art to our digital screens, and an impossible equation to the secrets of modern cryptography. Now let's bring it all into our world today. Our final architect shows that the legacy of April 6th is still very much alive and is actively shaping the science of today. I mean, think about it. From the weather forecast on your phone to the behavior of tiny subatomic particles, our world runs on predicting these incredibly complex systems. How do we even begin to do that? Well, it's done through the work of people like our final architect, Maria Esteban, a leading mathematician who was born on April 6, 1956. Maria Esteban is a master of applied mathematics. She's the one who creates the mathematical models that allow computers to simulate and predict the behavior of all these complex systems, from quantum mechanics to chemistry. Her work is basically the engine behind the powerful simulations that drive so much of modern scientific discovery. Probably the best way to think about her work is this. It's like building mathematical bridges that allow us to cross over and finally understand the invisible forces that are shaping our world. So, we've met an artist, an algebraist, and an applied mathematician. What could possibly connect them all? Look at this. You have an artist from the 1500s, a mathematician from the 1800s, and a scientist from our modern era. Different centuries, different fields, completely different worlds. And yet, every single one of them was driven by the exact same quest, to find the hidden pattern. From the rules of perspective to the underlying structure of equations to the laws governing our physical world, they were all, at their core, pattern finders. And that just leaves us with a final thought. Their search for patterns gave us realistic art, modern cryptography, and the tools to model our universe. So the real question is, What hidden patterns are still out there, right now, hiding in plain sight, just waiting for someone to find them?